Nomenclature of boss no makamba is daily boss. So nomenclature of triple liaison Alcynes. So the simplest Alcyne that you have, like we gave in an example last time, is what's the simplest example? The simplest Alcyne is okay, you can Google. So the simplest Alcyne is acetylene with a chemical formula of C2H2. So acetylene is the simplest what's this? Alcyne. It has a hybridization of sp and bond angles 180 degrees with a shape or bien structure linear. These things that you're hearing sp, you also apply them with your liaison chimique. There's a part where we're going to start doing liaison chimique in Chimie General, where we will deal with how bonds are formed. So when I say angle shan, you're also supposed to take note. It's not only SP, SP3, SPD where you have angles. You even have angles for molecules like say which molecule? Which one? Okay, let me say bromine, not bromine, boron. When boron bonds with fluorine, then fluorine can bond with bromine with 4 different fluorine atoms. So when boron bonds with fluorine, it can form 4 different bonds with the atom bromine. So when you go to liaison chimique, we are going to look at structures. So their structures are, maybe it's going to be bipyramidal, tetrahedric. So their angles also change. You have 190.5, some are 120, etc. So in liaison chimique, we are going to understand all those principles. It's a topic called the VSEPR theory, the valence shell electron repulsion theory, the VSEPR theorem. Yeah. So nomenclature of alcyls, that is, they have triple liaison, and their general formula is CN C2N minus 2N minus 2. So we have again the ones, there are 2 types. There are those that they're saying that they are vrai triple liaison à l'extrémité. Then we have those ones that are disubstituted. So like Taonga said last time, we had linear and ramifié. This disubstitué is also like ramifié. Vrai is like they're just straight chains, just like straight chains, linear. So we just justify this formula. So we count how many carbon atoms do we have in this molecule. So we count from anywhere. This one is not nomenclature. I'm just justifying what this formula here stands in for, like for this compound and for this compound. So we have 1, 2, 3, 4, 5. Now up 6 and 7. So 1, 2, 3, 4, 5, 6, and 7. Same applies to this one. So you can start from this side. 1, 2, 3, 4, 5, 6, 7. And what's 7 times 2? 7 times 2, Shinga?
14.
Minus 2?
12.
Exactly. So C7H12. This is the formula here. For this one, we are going to have 1, 2, 3, 4, 5, 6, 7, plus this one, 8. So you're going to have 8 carbon atoms. What is 8 times 2?
16.
Minus 2.
14.
So this is just a justification of this formula here. This is just a general formula. So we have les alcynes vrais, les alcynes disubstitués. So when we also count this one here, we are going to have 1, 2, 3, 4. That's 4 carbon atoms. And what's 4 times 2? That's 8 minus 2, that's 6. This is our general formula. This is our chemical formula. So same applies to this one. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So it's 7 carbon atoms. 7 times 2, 14, minus 2, 12. Ça va? Any questions? No questions?
No. Yeah.
Okay. So now we come to nomenclature. So the same, okay. The goodness that I am using a polycop that is written in a very, very loud language. Says the nomenclature du hydrocarbures dont la structure contient des triples liaisons carbone-carbone est réglé par les mêmes règles. It's even in bold. Même règle, même. What does même mean? The same rules used pour nommer les alcynes en remplaçant. We only replace the suffix ENE par YNE. C'est clair? Is it clear? The same
Oui,
rules,
c'est clair.
les mêmes règles est réglé par les mêmes règles utilisées pour nommer les alcynes en remplaçant les suffixes INE par YNE, YNE. That's all. I think we are done for this part. We can continue. Tef. So that is what you're supposed to do. Just replace the terminaison and apply the same rules. Everything remains the same. Everything remains the same. So they're saying ethylene, C2H2, which is non-usual acetylene. So we count for this one. We start. So for this one, I'll be a bit fast. So we'll just choose examples. We'll start with this one. We'll do this one. We'll also do this one. Then which one should we go? We go for this one and this one and this one. We skip this one because this one and this one may stand in for the same. Or maybe we do this one, and this one. Choose. Is it HEP? This one, this one. Tell me which one we should go for. Examples. I can't do all of them. It's the same rules, but with a bit of advancement there and here. Which one? Sangan, fast. Huh? This one, or this one. Or maybe we pass.
The second one and the third one.
The second or the third one?
Yes.
And the third one. Is everyone okay with that one? Second one and the third one.
Yes.
Okay. So we are saying les mêmes règles. So rule number 1 is a chain principal. Chain principal should contain the highest number of carbon atoms. So we are counting either left or right. That's going to be 1, 2, 3, 4, 5, 6, 7. Now, rule number 2 is the position of the double bond, the triple liaison, or the substituent. So now we are saying the triple liaison is what we are going to consider first. Then we are going to consider the substituents if there are any substituents that we have. So in this case, we are counting from a right. This is from our left. So 1, 2, 3. At position number 3, we have our triple liaison. 1, 2, 3, 4. At position number 4, we have our triple liaison. So which index is less, 3 or 4? So it is our 3. And how many carbon atoms do we have here? We said we have 7. So the prefix for 7 carbon atoms is called hepta. It's called hepta, and the position of the carbon atoms is at of the triple liaison. Sorry, the triple liaison is at position number 3, and our terminaison suffix will be YNE. So it is la chaîne principale, la position de la double liaison ou bien triple liaison, et la terminaison ou bien la suffix, ou bien les suffix, not la, les suffix. So that is a nomenclature for this one. So it's going to be hep, hep, 3, ein. Now, there is supposed to be an A here. Now, you guys have learned that Y is also part of, is it one of those that also forms, is it what we call the liaison? Is it what do you call it? Is it liaison or bien liaison in French? You guys are from doing grammar. This is organic chemistry, nothing to do with grammar. What do you call it? Liaison or bien
We
liaison?
learned that.
Tell us, man.
Zero.
What did you learn? You learned that Y does what?
We learned that it's part of the vowels.
Like
we take it as a
voila. You guys are francophones. You guys are francophones. So we also take it like a vowel here. So because Y is also considered to be a voyelle, we are going to omit the A here and let this Y stand there. So it's going to be hept, 3, ein. Yeah, ein. Hep 3, ein. Then example number 2. So example number 2, la chaîne principale, that is the one that contains the highest carbon atoms. So we are going to start counting either from our left or from here, from there. So we say 1, 2, 3, 4, 5, 6, 7, 8, 9, or 1, 2, 3, 4, 5, 6. So which one is the longest chain? The one that contains the 9 hydrogen atoms. So at what position do we have our double liaison d'après la règle 2? D'après la règle 2. So the double liaison is positioned at, the triple liaison is positioned at number 2. The triple liaison is positioned at number 2. Then when you count from the other side, that's 1, 2, 3, 4, 5, 6, 7. It is positioned at number 7. So 2 is lower and 7 is greater. And rule number 3 states we are supposed to give the triple liaison or the substituent the lowest index possible. In our case, the lowest index possible is 2. So we are going to have a 2, and our prefix is 9. For 9, we call it a nona. We call it a nona. Then the position is at number 2. Then we also have another thing. The other thing here is the substituent. So the substituent is at position number 1, 2, 3, 4, at position number 4. So the substituent is also called an ethyl. It's called an ethyl. We are going to have position number 4 and the substituent with the name ethyl. Then the chaîne parent or bien principal is going to be called a non. Now, like I said, okay, even though I said my book is with correct answers, I made some errors, one or two, but we'll correct them as we go on. So we are saying A and Y, these two cannot appear together. So the A here is supposed to be cancelled. So it's going to be non de ein. Non de ein. Non de ein. C'est clair? Any questions?
I have a question.
Alhamdulillah.
On the same nona de ein, right? Does that mean since the nona won't like that leave the A there with Does that mean that you also cancel the A because the A is like also is
Oh
also a vowel?
that's what I'm saying. Actually, let me even do this. This is what I'm saying. We are supposed to cancel the A. I'm saying, I say it there. Even though last time I told you that the answers I've given in this book are correct, 100% proven, but I made a few errors. This is the correct way you're supposed to write. It's supposed to be non de ein. Is it clear?
Yep.
Okay. So I also include this last example. So la chaîne principale, c'est lui qui contient le plus de carbone. So we count, here this is where now we count with preference over the triple liaison. Is it clear? We count from the triple liaison. So just like the Alcynes, it's the same things. So we say 1, 2, 3, 4, or bien 1, 2, 3, 4, 5, 6, 7. So it becomes a 7-chained hydrocarbon. And at position number 1, we have a triple liaison. And the terminaison is YNE. Then at position number 3, we have an ethyl substituent. Is it clear? C'est clair?
Oui, c'est clair.
Alhamdulillah. It's like this part is clear, eh? It's clear, eh? That is clear, eh? So,
Yes,
la même
yes,
règle.
clear.
La même règle. La même règle. C'est la même chose. It's the same thing. It's the same thing. For nomenclature, the secret is practice these nomenclatures. Just go on YouTube, on Google, and say nomenclature worksheet with answers. It's going to come like a PDF. Then you solve. You check answers after you're done with your answering. Then at the end of the day, if you continue practicing, you'll be looking at compounds just from me. Like you'll be looking at, oh, this one is 2,3 dipropyl phenyl, shan, all those things. So it's all about practice. Now, there's this one here we are going to look at now, the fifth rule. The fifth rule is the multiplication factor. Now, we are going to now apply rule number 1, which states we are supposed to look for the chain principal, and the chain principal should contain the highest number of carbon atoms. The chain principal should contain the highest number of carbon atoms. In this case, our chain principal, we either start from this side or this side. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ou bien 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ou bien 1, 2, 3, 4, 5, 6, 7, 8. So we are saying if you have a double liaison and if you have a triple liaison, we are supposed to, first of all, have the chain that is longest and contains the maximum number of either double liaison or bien triple liaison. Unfortunately, the carbon atom cannot form 4 bonds with another carbon atom. Is it true or it's false? A carbon atom cannot form 4 bonds with another carbon atom. Is it true or it's false? Tell me, is it true or it's false? A carbon atom will form 4 bonds with another carbon atom. Is it true or it's false?
It's false.
It's false. Why?
Because carbon and carbon have got a double bond.
Eh?
Yes, it's a double bond. Wait, no, I'm not sure.
Carbon and carbon have a double bond. Please help a sister here. Does carbon, okay, in a situation where carbon is bonding with another carbon, will it form a 4? Will it form liaison 4 à la puissance 4 if there is such a case? Will it form true or false?
I think it can form
It can form.
if it's if it's a molecule of carbon, of two carbons.
Give an example of that molecule, please.
Not sure of the example, but not sure. I was just
Okay.
thinking that maybe it can form.
I
Okay,
think it can't form because of the electronic configurations of the electrons. Because maybe one might remain something like that.
Okay.
Dalis, so
Another
I
one.
have a suggestion.
Uh-huh.
Okay, I'm just thinking. You said carbon is always like linked to 4 other atoms, right?
Uh-huh. Yes.
So if the other carbon has got four lonely electrons and the other carbon has got 4 lonely electrons, they can come together and move together, relate with each other.
Uh-huh.
So it's possible.
So
That's what I think.
So a carbon can form 4 bonds with another carbon atom.
Yes.
Is everyone okay with that? Or maybe there's someone who thinks maybe it's otherwise, it's wrong. No, we are all here to learn. We're all here to learn.
I don't know.
Others, what do you think? Can a carbon atom form 4 liaisons, 4 bonds with other carbon atoms? Is it possible? Can one carbon atom?
All right. Can I just try to justify my answer?
No. Okay. Let me rephrase the question. Maybe you didn't get me correct. I'm saying one carbon atom forming 4 bonds with another carbon atom. They're just 2, and they're forming 4 liaisons. 4. Can it happen? Kaunga, can it happen? You're the one that
repeat the question again.
You have a carbon. You have got 2 carbon atoms. You have got 1 carbon atom. Let me just write it here. You have where is this pen? You have where can I write? Okay, I'll write here. You have this carbon forming 1, 2, 3, 4 with another carbon. Is it possible? That's my question.
I think it's possible because
yes, I think it's possible.
because carbon. It's possible because the carbon forms 4 bonds, and since a carbon has an electronic configuration of 2,4, which means it needs 4 other electrons for it to be stable. Which means if there are 2, and each of them needs 4, so they'll form bonds in a covalent bond, which is they'll just share electrons. I think it can do
I think
that.
it's impossible. That's my thought, because I'm sure there'll be, like, if you put 1, 1, 1, I don't know, but I think it's not.
Okay,
It's
so
not
we leave this
possible.
question for Chimie General.
Simple.
We leave this question for Chimie General. So this is your research, right? So your research is, can the carbon atom form 4 bonds with another carbon atom? So I'm hearing a lot of interesting answers. So to make it interesting, you guys will research, and this research now you're supposed to submit your answers. So the research. Can you guys get me?
Yes,
Okay.
Yes.
I thought my network is cutting. Yeah. So your research is to research on. Now this one you're supposed to respond. I want to see those answers. I want to see those answers. Can a carbon atom? If you're writing, you should take note. Can a carbon atom form 4 other liaisons, or can it form 4 bonds with another carbon atom, like carbon to carbon, carbon to carbon? Then you give me justification. If it's drawing diagrams, I don't know. May just want the answer. Can it or it can't? Or see. So we continue. The nomenclature of cases like this here, where you have a triple liaison, 2 triple liaison. We said rule number. Okay, we add this rule. We call it rule number what? We call it rule number. we'll call it rule number 4.5, because rule number 5 is where you are supposed to use the multiplication factor. So we'll call it rule number 4.5, where we have 2 or more liaisons in one chain, and we are supposed to consider the longest chain possible and the maximum number of liaisons, that is either triple or double liaison. So now in our case, we have this chain, which is the chain principal and contains the maximum number of double or triple liaison. So we are saying the triple liaison will always take priority. So the priority in this case starts from this side. We are going to start from this side. 1, 2, 3, 4, 5, 6, 7, 8. At position number 8, we have the other triple liaison. Then not only do we have a triple liaison, we also have a substituent. A substituent at position number 4. And this substituent is called a methyl. This substituent is called a methyl. So our nomenclature therefore would be, we said this whole chain contains 10 carbon atoms. It contains 10 carbon atoms, and at position number 1 and position number 8, we have a triple liaison. Now, a triple liaison is denoted by the terminaison YNE. Then rule number 5 now, we are rule number 5, which states when you have 2 or more triple or bien double liaison, we are supposed to use the multiplication factor, which is di, tri, tetra, penta, etc. Then in this case, we have 2 that are repeating, so it will be a diene. So we are going to call this chain principal deca with diene. Now, like I said, I know my answers are 100% correct, but some things I was missing out. Tuma katiria pa, you put ka dash like that. You put a dash like that. So please don't forget, when you are doing these nomenclatures, don't forget to put my dashes, methyl, like that. Like that. Right? So to my dashes is very important in a UPAC nomenclature. So this is then at position number 4 we have a methyl. At position number 4 we have a methyl. So it will be therefore 4 methyl deca with diene. Is it clear? Is it clear?
So for the diene, the last part, you can't remove the I because the I is a vowel and the
no,
Y.
no. If we remove it, nice question. If we write it like this, if we write it like this, it will not show that here you're actually talking about 2 of these things. Like I said, this shows that we have 2 of these. Now, if we remove the I, it's just going to be a it's going to be a diene. Now, what's a diene? In organic chemistry, what's a diene? It's nothing. You see, it's nothing. So we're supposed to make sure that we put the I to show that we are talking about the multiplication factors of these double liaison or bien triple liaison or bien the substituents that we have in a question. Is that clear? So if we remove the Y here, it will not have meaning, in the sense that it will not also justify that we are actually interested in these 2 positions or these appearing liaisons that are coming twice. They are double, they are identical, and they are repeating. Yeah. So is it clear, Mutale? So
Yes, it is. Thank you.
you're welcome. So this example, we'll skip it in. So maybe na pale maelewa kama professor nakana kucha example nzio limba. So tizacha ya. So we consider the chain principal. Chain principal contient combien des atomes de carbone? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Have I counted correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Exactly. We are 10. Then because it's this this thing when you do asymmetry, it's almost like the same thing, right? It's almost like the same thing. It's the same thing when you do symmetry. It's like the same thing. So you guys have learned symmetry in mathematics. We apply symmetry here. So it means when we either start from this side or start from this side, c'est la même chose, ça reste la même chose. So counting from our right-hand side to our left-hand side would be, we said right-hand side there. 1, 2, 3. At position number 3, we have a double liaison, triple liaison. Number 3, number 4, number 5, we have another triple liaison. Number 6, number 7, we have another triple liaison. So this triple liaison is found at position number 3, 5, and 7. 3, 5, and 7. Then at number 2, we have another substituent. We have another substituent. Same applies to position number 9 here. We also have another substituent. And the substituents are the same. The substituents are the same. So before we go to this part, we have to deal with this one. We are saying a 10-chained hydrocarbon is called a deca. Now, that's the prefix. Now, at position number 3, 5, and 7, we have the triple liaison. We have 1, 2, and 3. The terminaison is YNE. The multiplication factor here becomes 3 because we have 3 identical triple liaisons. It now becomes triene. Then we come to this side. Is it clear on the chain principal, the prefix, and the terminaison with the positions of the triple liaisons? Is it clear?
Oui, c'est clair.
Alhamdulillah, alhamdulillah. So we have substituent at position number 2 and at position number 9. Now they are at position number 2, we have 2 identical encore. We have 2 identical encore. We have 2 identical encore. So at position number 2, we have a methyl and another methyl. At position number 9, we have another, methyl and another methyl. So in nomenclature, what we do is because they share the same position, we also share the same number. We are going to say 2, 2, because at the same 2, there are 2 over, maybe if I take this route of explanation, it will confuse people. There are 2 methyls at position number 2. Right? There are 2 methyls at position number 2. So we're going to say 2 for this one and 2 for this one. Now for the 2 of them, we are going to say 2, maybe let me just show it with a representation a bit because it will bring questions. So these 2 will stand in maybe for this one here, for this first one, and these 2 also will stand in for the other one. You see, eh? So it's not because there are 2 of these. Why? That's why we are saying at the 2, 2. It can also be 3, 3. It can be 4, 4, 5, 5. No. So the 2 here just shows that at position number 2 we have this methyl substituent, and we have another methyl substituent at position number 2. Same applies to position number 9. We have 1 there and another one there. So how many substituents do we have? That is the methyl. We have 1, 2, 3, 4. So there are 4 of them. If there are 4 and they are identical, we use the multiplication factor. And therefore, the name will be 2, 2 for the methyl at position number 2, 9, 9 for one that is here and the other one that is there, and the multiplication factor, which is tetra, to represent or to denote the 4 repeating methyl alkyls, or the 4 substituents. Is it clear? Is it clear?
Yes, it's clear.
Is it clear for everyone?
Yeah, it's clear.
Okay. Alhamdulillah. So now this is the part where we talked about the arachidonium atom, the hydrogen. This is where Esther came in with the principle of oxidation, also known as dehydrogenation. Yeah. So when you remove a hydrogen atom from an alcyl, what do you form? Someone to read this way, dying. Someone to read this way. Okay. So when you remove one hydrogen atom from an alcyl, you have the formation of an alkylene. Is it an alkylene, something like that? So the same thing will be done if you have this as your substituent. You are supposed to name it, just like we named vanilla. Is it vanilla, also known as ethylene, etc. So that is it with the substituents that come from alcyls. So I think we have examples kuntanshuko of substituents that come from alcyls. Now, before we go to the substituents, someone might have a question. Say, okay, Daliso, now this is a question. What if you have a double liaison and a triple liaison? Was anyone thinking of that question? Where you have a double liaison and a triple liaison? Was anyone thinking of that question? Where you have a double liaison or a triple liaison? Or maybe everything was just like, no, shall never be like this. It will always be like this.
No, I thought you were going to go there.
No. As in my question is,
We already saw it.
you already saw it. You're just waiting for it.
Yes.
Bon.
Yes.
Bon. Okay.
Yes.
So we skip, fine. So here what is done is basically the table of priority, which you guys are supposed to keep per queue, states that the double liaison has a preference as compared to the triple liaison. So when you're naming, this one is supposed to come first, then this one is supposed to come second. But now the rule is the one that has the lowest index possible becomes the one that you start counting from. So if the double liaison was like, I'll start with this one, with the triple liaison. If the triple liaison is at the far end and the index that you are going to find for this one is the lowest possible as compared to that of the double liaison. If the index of the triple liaison is lower than that of the index of the double liaison, you start counting from the triple liaison. In the same way, if the index of the double liaison is less or bien lower than the index of the triple liaison, you start counting from the double liaison. So the rule is, I'll repeat, the rule is when you start counting, which one is going to start? Is it the double liaison or the triple liaison? You start from the one with the lowest index, either it being a double liaison or bien a triple liaison. Now, for the first example, we have a triple liaison which is starting, then the double liaison is later or last compound. Now, the index here, when we count, this one has the lowest index possible at position number 1, and this one here has the lowest index possible at position number 5. When you count 1, 2, 3, 4, 5 at position number 5. So because when you compare 5 to 1, you find that 1 is lower and 5 is greater. Therefore, we are starting from the triple liaison, then we are going towards the double liaison. We are starting from the triple liaison, going towards the double liaison. Now, in a case where you have the double liaison, then later on a triple liaison, we are saying we are going to start with the double liaison because it has the lowest index possible. It has the lowest index possible. So when we count, we are going to have 1, 2, 3, 4, 5. So the 5 is the position of the triple liaison. The position of the triple liaison. Position of the triple liaison. The position of the triple liaison. And therefore, when you are naming, hydrocarbons that have the double liaison, and the triple liaison ensemble. The terminaison, or bien the suffix, will now be en, either with the I here just represents if you're going to have a diene, a triene, and hence the suite. Same applies to the other part here. You can also have an I to represent the diene, all those things, the diene, triene, etc. But the bottom line is when you have a double liaison and a triple liaison in the same compound, in the same hydrocarbon, a double liaison and a triple liaison, this will be your terminaison. This will be your terminaison. This will be your terminaison. This is what you are going to be using. But there is another thing you're supposed to take into consideration. Even if this is your terminaison, the alkene, the double liaison, has priority over the triple liaison. Please take note. Even if we're using the en space YNE as our terminaison for a double and a triple liaison, if you have a hydrocarbon that has that type of arrangement, the terminaison or bien the suffix becomes ENE dash YNE. That is our terminaison. It's like a special terminaison for those compounds or those hydrocarbons that have got the the double liaison and the triple liaison. But take note that we here in the priority group, the priorities, the triple liaison is less. Its priority when you compare it to that of the double liaison, it's lower. This one is lower. This is like the reactivity series of these functions, right? So the highest you can go is the carboxylic acid. So the carboxylic acid is the highest. Whatever is below the carboxylic acid is considered to be less reactive. If we were to use the analogy of the reactivity series, I'm not saying the carboxylic acid is very reactive than the alcohol. No, I am saying with the analogy of the reactivity series, it means that the carboxylic acid here has the highest preference when it comes to nomenclature. At the end of the day, you are supposed to master this table. Not necessarily mastering it, but you're supposed to know which one has got a higher preference when you are dealing with nomenclature. So there will be questions where you'll be given a compound with maybe three functions. Let me just look for one compound with three functions. You'll be given a compound with three functions, and you'll be told to name it. So you are supposed to apply the rules of priority. Which one is more priority? Which one is going to come first? Which one is going to come last? And NC the suite. So before I even look for that compound, let's finish up with the nomenclature part. Then we look for a compound. I just explain what I mean by the table of priority. So we are saying the terminaison is ENE tire ou bien dash ENE. It can be ENE, but because we are saying liaison, we're supposed to have, what do you call it? A liaison or bien liaison. Those things we do in French. Because you have two vowels that are appearing at the same side or they are facing each other, we cancel one and leave the other. So here, the I is just to show that we can have a diene, a triene, a tetraene, etc. So the ending should always be EN-I YNE. Is it clear on this part? Is it clear on this part? Before we name this compound. Okay, because of the silence to be that everything is going well. So now let's name this compound. So we start counting. We are saying the double liaison or be the triple liaison having the lowest index is what we are going to start counting from. Now, in this case, the triple liaison is the one having the lowest index possible. So we're going to start and say 1, 2, 3, 4, 5, 6, 7. So it is a 7-chained hydrocarbon. So therefore, it means it will be called a heptane. A hepo, not a heptane, but hepta. it will be called hept. So we are going to now go to the positions. So at position number 1, we have a triple liaison. We have a triple liaison. A triple liaison at position number 1. Position number 1. Position number 1. Then at position number 1, 2, 3, 4, 5. Position number 5, we have a double liaison. Then, like I said, the terminaison will always be, this. So the I here just shows either a triene, it can either be a triene, diene, etc. Or it can also show the positions at which we are having these double or triple liaison. So in this case, for our example, we have them at position number 1, that is for the triple liaison, and position number 5 for the double liaison. So therefore, the name of the compound becomes hept 5 in ein. Is it clear? You're supposed to put a tier here also. Where is it? A dash like that. Is it clear for this one? Okay, so we go to the other example. So the lowest index possible in this case is the double liaison, and the double liaison here will take a preference. So we start counting, say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So it is a 7-chained hydrocarbon. Therefore, we are going to look for the position of the double or triple liaison with reference from the double liaison itself. So this is at position number 1, ein, and at position number 5, we have 1, 2, 3, 4, 5. At position number 5, we have ein, the triple liaison, at the triple liaison. Is it clear? Is it clear? Is it clear?
Yes, it's clear.
Yes.
Is it clear for everyone?
Yeah, but
My English is becoming boring, eh?
yeah, but I'm a bit behind on those letters, the J, the I, the K.
Okay. So we are saying the J and the I are just representing either the position, or bien they can also represent if we have multiple bonds or triple liaison. Like we are saying, we can have 3. We can have triene, diene, we can have tetraene, all those things, etc. So it can stand in for the multiplication factors, or it can also stand in for the positions of these double or bien triple liaison. Is it clear? Eh? Is it clear?
So like when you have okay, like when you have two triple bonds in one chain.
2 what? 2
triple bonds.
2 triple
and
bonds.
one, yeah, and one double bond.
Okay, so 2 triple bonds, right? Two triple bonds. And how many?
One double bond.
Okay. Something like this. Steph, is it okay?
It's okay. It's okay.
So we are saying preference goes to the one that has the lowest index possible. Now, in this case, which one has the lowest index? Is it the double liaison or be the triple liaison? Which one has the lowest index possible?
The double.
Double, exactly. So we're going to start counting. We'll say 1, 2, 3, 4, 5, 6. So we are at 6. 6, 7, at position number 8. Position number 8, 9, and at position number 10, we have another triple liaison. So 10, 11, and 12. So a 12 higher chained hydrocarbon is called a what? A 12-chained hydrocarbon. What is it called? It's called what?
Dodeca.
Both a second.
Yeah.
They are only double bonds. How are you counted twice?
I've counted twice.
Like you said
1, 2.
7.
I said 1, 2, 3, 4, 5, 6, 10, 7 at position number 8, position number 9, position number 10,
Yes.
number 11, number 12. Is it clear? Is it clear? Is it okay?
Yeah.
It's okay. So it's at position 1, 2, 3, 4, 5, 6, 7, at 8, which is this one here. There's a 9 there. There is a 10 there. There is 11 there. And there's a 12 there. Ça va? So, alhamdulillah. So it's called a dodeca. Now we are saying we are supposed to have a terminaison in this order. E, N, E, Y, N, E, like that. Now we are saying because there are 2 vowels and all those things, so we efface this one. We're going to have something like that. So I'm saying the I can stand in for the position of the triple liaison, the double liaison, or it can also stand in for a 3, if it's a trienne, if it's a tetraenne, etc. Now, if this is our terminaison, and this is a 12-chained hydrocarbon, our nomenclature will be like this. Because okay, the goodness is that we do not have a substituent, so it will be at position number 1. We have a double liaison. Tefio.
Yes.
At position number at position number 6, at position number 8, at position number 10, we have 3 triple liaisons. We have 3 triple liaisons. And we are saying the terminaison is supposed to be Y, N, E. Now, because we have 3, 1, 2, 3, we have 3 repeating identical bonds. They can be bonds, they can be substituents. Now we have bonds here, and there are 3, and they are identical. We are going to use the multiplication factor 3, or bien tri. So therefore, our compound, or bien hydrocarbon, would be called dode. Now, another thing to note, here, this A is supposed to be cancelled because you have a vowel there, you have a vowel there, you have a vowel there. You're supposed to cancel this A. So, like that, then your nomenclature is done. So the molecule or the hydrocarbon will be called dode 1, 6 with this trienne, something like this. Is it clear, boss?
I was thinking that maybe since the letters are different, if you want, like, if tri is being represented by I, you can just write I without writing tri there.
No. But you are never, ever supposed to just write I. The try here shows that you have 3 liaisons. You have 3. Now, in the case where you're saying we should remove You're saying we should move everything and just write I.
Yes, since it's representing 3.
No. You are never, ever. So never are you supposed to write. This is the same question that who is this that asked me this question? Is it Mutale? She said, okay, if we have like a die here and remove like a I because there is a liaison shanshan, we write like this. Apo. If you are working at the UPAC, it's immediate fire. You are fired with immediate effect. You are never supposed to just leave I and say no because there are 3. No, you are supposed to show the multiplication factor. The multiplication factor shows us. Take for instance, I give you. I don't know if I can call it a prescription. I'll use this example. Why? I'll use this example so that maybe it can stick the head. Like if you're working for the International Union of Pure and Applied Chemistry, they tell you to say, okay, you go and buy this compound, this same one. They tell you to go and buy this one. Where is it? They tell you to go and buy this. They tell you to go and buy this. Now you going there, you just going there with this name. They will know that okay, this compound has a double liaison at position number 5. It has a triple liaison at position number 1. They will know why, because there is a guide. The guides are the positions that you're putting here, the 5 and the thingy. Now, if you just put I, someone will be like, what is this I standing for? What is this I standing for? Okay, I'll also ask you, Mr. I don't know if it's Mr. Who. What would the I stand for if you were to write this as like that? What would be the I stand for if you are asked to tell us what the I stands for in the compound? You will definitely not tell them because you'll be like, this I, it might mean something else. It might mean intelligent. It might mean anything. Now, the try that we put there, the try, the die, and all those things that we put there, it shows that this compound that you are looking for has 3 of these bonds, has 3 of them, has 3 of these triple bonds, has got 3. It has got 3. It has got 3 of them. It shows that there are 3. There are 3. There are 3. It shows that there are 3 of them. Even when you're showing, when you're giving this nomenclature thing, it's not just that you are supposed to show that no, this is how you write the name. No, these names that we're giving these compounds, they just show, it actually tells you that, okay, this compound comes from this family, this compound comes from this family. So the names that we are giving here, it's not just the style that we are writing, no, because, no. These names that we are giving also help people to understand what we're trying to talk about. Because if we just put the I there, I don't know if it's, who is that? Mr. Nan? Who is it asking that question? Mr. Who? Mr. Who?
Bless.
Mr. Bless. So Mr. Bless, please, the I that you put there will not mean anything. It will not mean anything in a case where someone's going to ask you, okay, we want to get this compound. Now, how many double liaisons or triple liaisons does this compound have? We want to know because we just put I there. I can mean anything. But if you put the try, if you finish everything and say try in, it would mean that, okay, there are 3 double liaisons, or beyond there are 2 double, or there are 3 triple liaisons, or beyond there are 3 double liaisons, because you put that multiplication factor. That multiplication factor is very important. In the same way, I'll give an example of an example of toluene. Now, for toluene, I'm just explaining this to just give more light. In this example, the reason why we are saying methyl is because the toluene molecule, or bien the methyl benzene molecule, it's also called toluene. It has a methyl function. Now, if we just decide to say, okay, this here is called benzene, this is called benzene. It's called benzene. So we'll just say, no, it's going to be benzene. It will mean totally something else. It will mean totally something else. Benzene and toluene are 2 different compounds, but toluene is a derivative of benzene. So you get it. the substituents that we are putting here, methyl, phenyl, all these things, they are very important. It's just that it's not just nomenclature that we're just saying, no, we're going to include them. No, they are important because it shows that, okay, this is a benzene molecule, and somewhere there is a methyl bonded to it. Now, when you come to the nomenclature of these things, you're going to see we're going to have the para, the ortho, and the meta. At position number 1 and 3, you call it this. At position 1 and 4, you call it this. At position 2 and 1, you call it this. So it shows that, okay, if the methyl is found at position 1 and 2, it will be called this. So even you'll be like, okay, though this compound is para-oriented, this one is ortho-oriented, this one is meta-oriented. Just by looking at the nomenclature, you'll be able to tell that, okay, this is a para-orientation, this is a meta-orientation, and this is an ortho-orientation. Is it clear? So please, the I, you should never write I. Never, ever, never, ever write I. Because if you just put I there, take it that you are working for the International Union of Pure and Applied Chemists and you put I. It means if that was medicine, you have killed a lot of people. You have killed a lot of people. Why? Because the nomenclature that you put there was not correct. So please, whenever you have multiple liaisons, triple liaisons, double liaisons, triple or bien quatre substituents, you are supposed to make sure you put the multiplication factor. Make sure you put the multiplication factor. Yeah, are there any questions? Are there any questions so far? Are there any questions so far?
Yeah, question.
Uh-huh.
Yeah, so yeah, so how do we write it when substituents is coming?
Okay, substituents coming, eh? Okay, nice question. Any other question? What's the same one?
No, my question was that how do we then use those to my I, J, and 10?
No, look, these letters that you've seen here, just show that there can be a number that can be positioned at position number 6, position number 7, position number 8, position number 9. Now, in a case where you have a diene, a triene, and all those things, it does not change anything. It does not change anything. In other words, the I there can be a position of the double liaison. The I there can stand in for a triple liaison. The I can, or the J, the K, all those letters that you've seen can stand in for any type of liaison and its position. So they just basically, how can I simplify this? You see, when we are representing, I know the guys have not done matrices. When which one? Okay, I'll use this equation. There's an equation of a straight line. You know that the equation of a straight line is written like this, eh? Says y is equals to a x plus b. Another person will write it like this: y is equals to m x plus b. So the two equations are the same, but the representation is different. The m here signifies or denotes gravity. Same applies to the a. It does not change anything. It's just a representation. So what I'm trying to say is the K, the L, the M, and all those things, these ones, let me just show you. The J, the J, the K, etc. They just represent the positions of these substituents. They just represent positions. So we're saying at position I, maybe say, let me use this type of writing I, maybe to make more sense. So we say I, we say I, position I, and position J. So this molecule became helped I like that. J I. So to just give more light on what I'm trying to say. So the I and the J just show the positions. What is the position for the triple liaison? For this example here, this example, what's the position of the triple liaison? Hmm?
1.
Is it
Oh,
position
6,
number?
sorry.
Is position no, you said position. You said position 1. Tips. You said position 1. Now, position 1 is not correct because we said that in the preference table, the double liaison will come first. The double liaison will come first. So that's why we have a position number 6. That is why we have a position number 6, because the double liaison in the preference table is the one that has the highest priority as compared to the triple liaison. Now, what is the position of the double or the triple liaison? We say this position at position number 6. Steph. So this is where now we say, okay, at position number 6, we have at position number 6, we have our triple liaison. Then what's the position? What's the index for the double liaison? It's at position 1. It's at position 1. So basically, the I, the J, and etc. They just represent the indices that we can have. It can also represent the multiplication factors. It can also represent the multiplication factors. It can also represent the multiplication factors. We can say, okay, if we have another triple liaison on the other side, we're going to say, okay, maybe let me use another letter. I'll use X. X can denote the number of triple liaisons or be the multiplication factor that we can use for this one. So in the case where we have 2, we are going to say, okay, it will be called a diene, like that. So the K, the L, the M, the J, the P, the Q, the R, S, T, V, W, all those things, they are just representations of either the multiplication factors, that is the di, the tetra, the tri, the penta, the hexa, etc. They can represent the multiplication factors. They can also stand in for the position of the double liaison or bien the triple liaison. Then another thing you're supposed to take into consideration is that the double liaison has a higher preference as compared to the triple liaison. Therefore, when you're giving its nomenclature, when you have a position like this one here, you have 1 at position number 1, and the other one is also at position number 1. Now, the question will be, which one are you going to start with? So we are going to start with a double liaison because it is higher in the preference table as compared to the triple liaison. That is why you have position number 6 for the triple liaison and position number 1 for the double liaison. Now, there's a question that what if this thing is substituted? Tiff, was it the question? Was it the question? Hey, what question am I in?
Yes, it was the question.
Oh yeah. Yes.
Okay. So in a case where we have a substituent, so we are going to count same principles. So we are saying the double liaison is one that takes a preference step. It takes the preference. So our direction will be this. So we are saying at position 1, 2, 3, 4. At position 4, we have the ethyl. At position number 4, we have the ethyl. Then at position 5, we have what do we have?
Methyl.
Methyl. So, comme toujours, we are going to apply rule number 4, alphabetical order. So, alphabetical order, which one comes first? It is this 4-ethyl. Cinq methyl. Hep. Est-ce que ça va? This will be the nomenclature of this compound. Any questions?
That's clear.
Is it clear for everyone?
Yes.
Very clear. So I can ask questions. Like yesterday, I can ask questions.
Yes, you can.
Okay. So if there are no questions, we go to the last part of today's school, which is the saturated hydrocyclones. You guys know what a cyclone is? Geography. Cyclone.
A cyclone.
Cyclone. Not say organic chemistry. It's not organic chemistry. Cyclone.
Chisamechenze uchosa mvula okusamwera ku Tanzania.
Exactly. Something like that. Yeah, the same thing. It's chemistry. It's just geography. So today we are going to look at the cyclic hydrocarbons. So like we said in the introduction, we said organic chemistry is divided into two parts. There's what you call the aliphatic part and the aromatic part. So in the aliphatic part, we looked at straight chains hydrocarbons. That is the alkenes, the alcynes and alcynes, the ones with triple liaison. Then we are also, those ones are straight chains or bien substituted hydrocarbons. Now we're going to look at the other part of aliphatic hydrocarbons that contains cycles. You're going to have cycles, like cyclohexane, cyclohexane. So in the cyclic nomenclature, nomenclature is the simplest. It's the simplest nomenclature ever. What you just do is, if it's a triangle, you just say cyclo triangle, and you're done. Cyclo square, you are done. Cyclo is a pentagon, you say cyclo pentagon. So basically, the cyclic type of nomenclature is based on just like a cyclo thing. Like a cycle is what changes everything. Now you just count also, which one is the longest chain, but the cycle will always have the longest chain of carbon atoms. So in this case, if we're to count, this is 1, 2, 3. So how many carbon atoms we have there? We have 3. What do you call a hydrocarbon with 3 carbon atoms? A 3 carbon atom hydrocarbon is called what? Propane. So therefore, the nomenclature will be cyclopropane, not cyclotriangle. It will be cyclopropane. That's what I'm saying. The nomenclature for cycles is the simplest. Cyclo. Propane. What about the next one, it will be what? For the next one, it will be what?
Butane.
Cyclobutane.
Cyclobutane.
Cyclobutane. Why butane? Because there are 4 carbon atoms. That is 1, 2, 3, 4. For this one, we start anywhere. 1, 2, 3, 4. 1, 2, 3, 4. Anywhere. Cyclobutane. Butane. Then this one is 1, 2, 3, 4, 5, 6. 6 steps. 1, 2, 3, 4, 5, 6. So 6. What do you call a hydrocarbon with 6 hydrogen atoms?
Hexane, cyclohexane.
Cyclohexane. The ladies, is it clear?
Very.
Alhamdulillah, alhamdulillah, alhamdulillah. That's all. That's all with these tables, these diagrams you are seeing. Now, to just summarize this whole part here you are seeing, okay, we'll do this. We'll do this. So now, to just summarize this part, we are going to give this part a substituent, and this one also a substituent there. Same applies to this one, and maybe something like that. Then this one here, so this will just summarize this whole topic. So when you're naming such compounds, the cyclopropane, the cycles, the nomenclature still remains the same. The nomenclature still remains the same, but you just have to add in the substituents. If there's substituents, if they're double liaisons, you're supposed to add the double liaison. If there is a triple liaison, you add it as well. If there are multiplication factors that you're supposed to apply, that is if you have 2 identical or more substituents, triple liaison, or bien double liaison. So in this case, the chain principal contains 3 carbon atoms, and we are calling it propane. Now, it's a cycle, and it will be called a cyclopropane. That is what we built from, right? It's called a cyclopropane. Now, there's something else. There's a methyl there, and there's an ethyl there again. There is a methyl and ethyl. So in a case where you have 2 substituents like that, you have ethyl and methyl. The question that comes in is, where do I start counting from? So you always start counting from the one that appears first in the alphabet. The one that appears first in the alphabet is where you start counting from. In our case, the ethyl is the one that comes first in the alphabet. It's E. And the methyl comes later in the alphabet. So in order of alphabetical preference. So in this case, the way or beyond the root we're going to use will be 1, 2, and not 1, 2, 3, because we are always looking for the lowest index possible. The lowest index possible. Therefore, the name of this compound would be 1 ethyl two methyl cyclopropane. Propane. Chop. Is it clear for the first one? Is it clear for the first one?
Yeah, it's clear.
Okay. So if I was to include, okay, so if I was to include another one, another methyl, it would be at position 1, at position 2, and 3. So let me show whether I go 1, like that 1, 2, or be on 1, 2. So let me show the methyl is still at position number 2. So it would be 1, 2, and 3. So at comma 3, we have a 2, 3, and because we have two substituents that are identical, we are going to have now a dimethyl, like that, a dimethyl, like that. Is it clear for this part? So if we have two substituents, that is at position 2 and 3, that is the methyl, it will be 1-ethyl 2-vegetor dimethyl cyclopropane. Is it clear?
This is when I've just come. My network just went, so I
Bon.
didn't get the part
Okay,
where
okay.
you started doing the substituents.
Okay, so we are going to say everything and we are going to explain. So we are saying when you have substituents, like this is a cycle, and the name of this cycle, we built from the cycle and we said the cycle is cyclopropane. Why is it cyclopropane? Because we have a cycle first of all, and we also have 3 carbon atoms. That is 1, 2, 3 carbon atoms in a cycle. 3 carbon atoms in a cycle. It's called cyclopropane. Then we added substituents. We added one there and the other one at the far end. Now we are saying for us to give nomenclature to this one, we are supposed to consider the order alphabetic. So in other words, if you guys are following very well, all these rules can be, rule number 1 can come, rule number 4 can come on position number 1, rule number 1, rule number 1 is always rule number 1. But rule number 2 can come at position number 3, rule number 3 can come at position number 2. For as long as you are obeying these rules, everything will be okay. Because we have actually gone to rule number, is it rule number, which one is it? The one for alphabetical order. Which one is it? Rule number what? For alphabetical order. Rule number? Rule number? Oh. That one, we are conquer. So you must conquer. Rule number. So rule number 4 is alphabetical order. Rule number 4, we are supposed to align these substituents in their order of alphabetical preference. So we are saying the ethyl comes first, then the methyl comes first, because the E comes first in the alphabet, and later on you have the M. So when counting, you are going to count with preference, that is coming from the alphabet, with preference from the order alphabetic. So counting will be 1, 2. So we are saying the name of this compound will be 1-ethyl at position number 2, we have methyl and cyclopropane. Cyclopropane. Sava. Now we said.
So what you're trying to say is that the triangle that's there, the cyclopropane, you can't start from anywhere counting the carbon atoms because you've named it 1. So meaning where it's attached, that's like where you're going to start counting from.
Like this, eh? So if it's like this, if this is how it was. If it's like this, you start from anywhere. You can start from here 1, you can come here 1, you can come here 1. But if there is a substituent, for example, we have a methyl substituent or ethyl, and we have another ethyl there. We can start from anywhere because in the order alphabetic, any can start. You can start from there 1, 2, or there 1, 2. If we now include a methyl, the order would be, if we start from here, we are going in this direction like that. because with preference in the alphabetical order, E has to come first. So when we start from here and say 1 and come to this one 2, it means we have obeyed the alphabetical order, because this is an ethyl and this is also an ethyl. If we go like that, it will be wrong, because the ethyl is supposed to have the lowest index possible. Why? Because E comes first in the alphabet. So the order will be either in this direction, like that, or it will be in this direction. Then this one comes at the end. So basically, what we are using here what we are using is the alphabetical order, just the alphabetical order. But when we have double liaison, triple liaison, now this is where now we have a bit of changes. Is it clear so far with cyclopropane and the substituents there? Is it clear?
Yes, it's clear.
Then I gave another example. Say, take for instance, you have another methyl there. You have another methyl there. So because you have another methyl and they are appearing twice, we are going to use the multiplication factor. The multiplication factor is rule number 5. Rule number 5. So the order we are going to take can either be in this direction. We can go in this direction like that, or we can still go in that direction. Why? Because when we count here, this is position number 1, and this is going to be to position number 2. Sorry. When we count from here to there, this still remains position number 2. So because the methyls still maintain their positions, we can still go in this direction, or we can still go in that direction. Therefore, it will be 2, 3 dimethyl cyclopropane. Is it clear? Is it clear? Is it clear?
Yes, it's clear.
But foot.
I'm saying it's clear.
Oh, nambira but foot guys. No, we can still explain. Don't worry, we can still explain. Even from chapter 1, we can still explain. So now there's another one here. It's called cyclobutane. Butane. Now we have substituents at position, I don't know, this is position 1, maybe position 2, position 3. But because we have ethyl here, and we have another substituent at the same position, we still apply the alphabetical order rule. We still apply the alphabetical order rule. So at position number 1, we have, because the alphabet is what now determines where we are starting from, like where we're going to start counting from. The alphabet is what is helping us determine where we are going to start counting from. So we start to say 1 at position number 1, you have an ethyl there. At position number 1, you have an ethyl there. Again, at position number 1, you have a methyl there. And it will be called cyclobutane. So it would be 1 methyl, 1 ethyl, 1 ethyl dash 1 methyl cyclobutane. Cyclobutane. Same applies to this molecule compound hydrocarbon. If there was another methyl there, or bien an ethyl, if there was another ethyl there, we would have said a diethyl. In the case where we have 2 ethyls, we just include the position. This is 1, this is 2. Then we also come to this other side. Now, because this is another thing you're supposed to take note. In a case where you have such a question, say, name this compound, name this compound, name this compound. You are supposed to use the alphabetical order, isn't it? That's rule number 1. You are going to use the alphabetical order. Now, when you're using the alphabetical order, you also are supposed to look at which one of these is mostly substituted, which carbon atom is mostly substituted. The carbon atom that's most substituted is where you consider your number one. Where you consider your number one. Because I know some of you may say, okay, we're going to start from here and go like that. No, you consider the carbon atom that is mostly substituted to be your number one. Then later on, you come to your number two, like that. So it will be at position 1, comma, at position 2, you have a diethyl and another one, that is 1-methyl cyclobutane. So, like I said, when you have two substituents, like in this arrangement where you have one carbon atom with two substituents and one is substituted with one carbon atom, you are supposed to use the one that is disubstituted with two substitutes, with two substituents. That becomes your number one. So in our case, our number one will be this one. Our number two will be this one. Then number 3 and number 4, and say the suite, like that. Is it clear for this example? Is it clear?
For the cycloalkanes, we are not considering the issue.
Yeah, I can't get you. I can't get you. I can't get you. I can't get you.
I'm saying for this cyclo.
Mm-hmm. Mm-hmm.
You still can't get me.
No, I can't get
Yes,
you. I can't get you.
For this, it's a problem.
Okay, please type your question. Just type your question. Are there other questions? Are there other questions? Okay, okay. It's like everything is going as planned. Whew. So, okay, if we're going to wait for Mr. Is it Fumbani's question, then before we even get his question, we are going to answer this one here. So, we have a cyclohexane with 2 substituents. It's the same principle, We have a cyclohexane with 2 substituents. Now, the question would be, where are we going to start from? So this is a Ecriture compact for ethyl, and this is Ecriture compact for methyl. So in your exams, depending on where you're going, some professors would put this, some will put this. So ngati organic chemistry, question. So this is just the same as methyl. This is just the same as ethyl. So you should also be acquainted with different types of writings. Be acquainted with different types of writings. So in this case, we are saying the alphabet is what is going to help us determine which one is our number one. The ethyl comes first in the alphabet, then you have the methyl. So in order alphabetic, we are going to have our position here 1 and 2, 3, like that. The idea is we are always supposed to have the smallest index possible, the smallest index possible for our compounds. Therefore, the name would be, this is the same example I gave for this one. The name would be at position 1, you have 1-ethyl. 1 ethyl. Position 3, you have methyl. And a cyclohexane. Cyclohexane, like that. Then take, for instance, we had another methyl like that, another methyl like that, another methyl like that. So our counting would be, which one has the lowest in this possible? We have 1 here, 2, 3, and we have 1 here, 2, 3. So Salamem shows it will be 1, 2, 3, 4, 5. Add position number 5, and let's go like that. 1, 2, 3, 4, 5. C'est la même chose. Ça va être 3,5 dimethyl cyclohexane. Now, in a case where you have an ethyl there, it will be, the order will be 1, 2, 3. The order will be 1, 2, 3. Then you have your 4 and your 5. So the order will be 1, 2, 3. So at 1 and at 3, you have 2 ethyl substituents. That's diethyl three. So that's 1, 2, 3, 4, 5. Position number 5, methyl. Cyclohexane. Before we go to Mr. Fumbani's question, I'll just put another substituent here to just give more light on how we go about naming these compounds. Then we close today's session. So we're going to have another substituent. So the PR represents, what does it represent? PR. Huh? What does the PR represent?
Propane. Propane.
Propane. It's propane. It's propane. So order alphabetic, which one comes first in the alphabet? SP1. Which one comes first? E, M, P. Which one comes first?
E comes first.
E comes first. So ethyl comes first. After ethyl, what do you have?
We have methyl.
We have methyl. After methyl, what comes first? Second, last?
Propyl.
Propyl. Then you have your cyclohexane. So now we just give positions. The there's ethyl is at position number 1. Position number 1. The methyl is at position number 1, 2, 3. And the propyl is at position number 3, that's 4 and 5. Like that. Is it clear for all these for here, I've got another question pending. That's Mr. Fumbani's question, which reads, does it mean for these cycloalkanes we do not consider the issue of longest chain of carbon atoms? Can someone respond to this question if you understand everything? Are there questions? Any questions? Any questions? Okay. So those that have understood, please, can you answer Mr. Fumbani? He says, does it imply that these cyclohexanes, we are not considering the longest continuous chain of the alkane? Please, if there are no questions, someone wants to respond, okay? You can go ahead.
I think we are not, because well, for the name, when you look at the name of these compounds or these molecules, when you said for the cyclo thing is for like the shape. So for the cyclo name, it's dependent on the shape and the number of carbons that are there. So either way, we still have to count the number of carbons in that make up the shape. Then for the branching off, we have to look at the alphabetical order. Yes, like ethyl and methyl, which one comes first in the alphabet? You say ethyl. So yes, we'll name them according to that, and we'll start counting from like the first one, which is ethyl. Then yes, yeah, that's what I understood.
Okay. Any other additions from those that understood? Someone's on time.
Can I add on?
You can add.
Yeah, I think the counting of the shape, like it's showing us the number of carbons that are there, and that's showing us the chain. But those that are attached to the shape, those are substitutes. So we don't count them together with the shape itself. So counting the number of carbons is the same as counting the shape, the size of the shape. That's according.
Any other questions? Any other questions? Sorry, yeah, guys. Any other contributions? Any other contributions? So I want Mr. Fumbani to read this statement for us. This one here, till this full stop here. This way, this can sentence. So this one here, starting from here. You can read it in in French or in English. You just translate it if you want.
Okay. No. Just read it. La chaîne principale doit inclure le cycle si cette dernière possède plus d'atomes de carbone que ses ramifications et la numérotation des atomes de carbone individuels du cycle commence par attribuer à celui qui porte le substituant qui va être cité le premier dans l'ordre.
Has it answered your question?
Yes.
So, therefore, la chaîne principale doit être inclue dans la cycle si cette dernière possède plus d'atomes de carbone que c'est ramifié, et la numérotation des atomes de carbone individuels du cycle commence par attribuer l'indice 1 à celui qui porte la substitution qui va être cité la première dans l'ordre alphabétique. Therefore, the cycle will always be the chain principal. In the case of these two small chains that you're seeing, these two small ones, this is just a build-up. So, like I said, we said with alkanes, we'll be developing just parono. Later on, you see how some rules are disqualified. Like when you look at benzene, so the coup has ended, so the chain principal is the cycle. Chain principal is the cycle. Is it clear so far? Is it clear? The chain principal is the cycle. Is it clear? Is it clear? So now to just add on to what I'm trying to say. So there's what you call nomenclature des hydrocarburyl benzenic. So please, this is now, if you had your book in your hand, this is where you put it down. This is just like maybe an addition. When you're dealing with nomenclature of aromatic carbons like benzene, there's what you call, I was talking about the ortho, see, the ortho, meta, and the para type of orientation. These ones, when you're naming them, when you are starting to count, you count from the number one. The order is like that. You count from number one like that. If they are bonded on the first carbon and the second carbon, this is their orientation. Takuli, no, it is alphabetic, shan. No. If the bonding that you have is in the orientation of ortho, which is at position number 1 and position number 2, that is the order you are going to follow. That is 1, 2, ubia 1, 2. That is how it is. For meta will be at position 1, 2, 3, 1, 2, 3. And never like this. Never will it going to be like go uku. No, never, ever. It's the lowest index possible. It will either be 1, 2, 3, or 1, 2, 3. But every time we are dealing with this type of nomenclature, that is the benzenic substituent nomenclature, it is advised that we start from here, say 1, 2, and go like that. 1, 2, and go like that. But it's not a rule. It's not a rule that you are supposed to start from here all the time. No?
Question.
Yeah.
Quick question.
Yeah.
Do you mean that if at the left here there is an ethyl, we just still continue going, just following the methyl?
No. That's a very nice question. Very nice question. When you have a methyl, when you have an ethyl, you're not going to use the meta para type of nomenclature. You're not going to use the meta and the para type of what do you call it? The meta and chan, meta ortho para. You're not going to use that one. You're going to use the normal one. You're going to use the normal chain alphabetic, shan, all those things. But when you have two substituents that are the same and they are oriented at position 1 and 4, that is 1 and 4, 1 and 3, 1 and 2, you are going to use the ortho, meta, and para. That's if you have substituents of the same. They are the same. If they are the same. So if we had ethyl here, we would use the ortho para. Ethyl, we would use the ortho para. Ethyl, we would use the para, ortho, or meta orientation. But if you have methyl and ethyl, we are not using that. We are using the normal one. And the normal one states we are supposed to use the chain principal, benzene, and the alphabetical order is what's going to give us the lowest index possible for that hydrocarbon. Is it clear? Is it clear? So that was just an addition. When it comes to double liaison or bien triple liaison, the triple liaison takes priority. So ainsi de suite. Is it clear so far on the cyclones, the cyclic hydrocarbons? Is it clear? We are going to look at the benzene later on. I was just trying to add on Mr. Fumbani's question. So the cycle will always be the chain principal of the compound. It will always be the chain principal. Even though when you count like that, it goes wow, it's long. No, the chain principal will be this cycle here. It will be the cycle you are seeing here. Any questions before we close? So, any questions? Okay, so if there are no questions on several achievement portion, so the next time we come, we are going to look at this. So please, I ask you, please, when you go, I don't know if it's going home, or if you're at home, if you're in the road, the tram, you do this. Revise on how to name cyclic hydrocarbon. It's the same as the open chain ones. Now you just have cyclo-shanshan, still remains the same. Then we can start naming alcohols. Then later on aldehydes. Later on we go to carboxylic acids. Then we start doing organic chemistry. So if there are no questions, have a good weekend on several assignment projects.